So we're going to keep going with discrete random variables. And again, we're talking about or numbers or values that are whole numbers. They can't have fractions or decimals, anything like that. So now we talked about random variables. We talked about binomial. Now we're going to talk about geometric. The big deal about geometric is, there's one or more Bernoulli, or it's binomial with no fixed number of trials, with all the failures except for the last one where you get success. So let's think about it this way. It's if you say you're going to flip a coin and you're going to stop flipping when you get a head. You flip it the first time, you get a tail. Flip it the second time, you get a tail. But on the third time, you get a head. That is success because you wanted to get ahead. So that's all we're talking about with geometric distribution. So you're going to do something until you have success. So again, you throw a dart at a bullseye until you hit the bullseye. The first time you hit the bullseye is success, so you stop throwing it. It could take you 3 tries, 6 tries, 10 tries, but you keep going until you hit that goal. And I kind of think, I know this kind of sounds stupid, but I kind of think of geometric like goal because they both start with G. So when I'm looking at these problems and I'm doing something until I get success or I hit my goal, that's how I know it's geometric. So in theory, yeah, these could go on forever, and you have to have at least one trial. So the probability of P of a success and the probability of Q is the failure. And again, P plus Q equals 1. And remember, probabilities, we're talking about decimals under 1. So we're going to write it as the distribution approximates geometric with P, and that's the probability. So the mean of geometric distributions is 1 divided by P, and the standard deviation is the square root of 1 divided by P times 1 divided by P minus 1. All right, so for example, the probability of rolling a 3 when you throw a fair dice is 1 in 6. So what that means is if I have a 6-sided dice, for me to roll and get a 3, there's a 1 in 6 chance. It's true that no, how many times you roll the dice, I always have that 1 in 6 chance. Nothing changes about that. So suppose you want to know the probability of getting the first 3 on your 5th roll. So on rolls 1 through 4, you didn't get the 3. So that means you got a 1, 2, 4, 5, or 6. So that's 5 out of 6 chances that you're not getting the 3. So when you do that, you're going to do, for the first 4 rolls, you're going to multiply 5 over 6, and then the last one where you're successful is 1 over 6. So the probability of getting the first 3 on your 5th roll is 0.0804. All right, suppose that you're looking at students at your college who live within 5 miles of you. You know that 55% of the 25,000 students do live within 5 miles of you. You randomly contact students from your college until one says that they live near you. So remember, success is they live within 5 miles from you. Failure is that they don't. So you're going to test out what is the probability that you need to contact 4 people. Okay, so I've got 4 people I'm going to contact, and I'm defining success as they live 5 miles from me. Okay. So again, this is a geometric problem because I'm hoping I get it. So, and then remember, for each student, I'm going to be, do you live within 5 miles of me? Yes or no. So again, success is they do, failure is they don't. So if I want to find the mean, I would do 1 divided by 0.55. I get 1.82. Standard deviation, I just plug it in and I get 1.22. This bottom one here for the standard deviation, I do it in parts. I do this part first times this part, and then take the square root of the whole thing. All right, so let's talk about it. Let X be the number of blank you must ask before 1 says yes. B is what values does X takes on. C is what are the P and the Q. And D, what is the probability that you need to contact four people? All right. So let X equal the number of students you must ask until one says yes, they live within 5 miles of you. B is 1, 2, 3, all the way up. I know as you keep going is the total number of students. I started with 1 and not 0. All right, that's different than what we've done before. You start with 1 because if you haven't asked anybody, you haven't done anything. And you're saying, I want to ask these people, and you have to start with 1. Okay, P is 0.55. Q is 0.44, or excuse me, 0.45. All right, so how are we going to get that answer? So what is the probability you need to contact four students? All right, so I'm going to use Minitab, and I'm going to show you what to do. And again, if you get stuck, I have in here what to do. Okay, so I'm going to do students here. And I'm going to make this bigger because you can't barely see it. Come on up. Okay. I'm going to do 1, 2, 3, 4. Okay. And this is going to be the student prob. Okay. Just so I can keep it straight. A lot of times when you're doing a lot of these, I like to label my columns so I know. All right. First thing I want to do, and then again, it'll walk you through what to do here in it. I'm going to do calc, probability distribution, and I'm going to go to geometric. All right, I'm going to do probability. So my event probability again is 0.55. So my input column is going to be students, and my output column is going to be student prob. I'm going to do that. Okay, and again, you get stuck. It's right here. So then if I do it, I hit OK. So look, all right, it gives me all my probabilities. So let me go back to the PowerPoint to show you. So if I look on it and I get my answer is 0.0501. So the probability that you need to contact 4 people is 0.0501. That's how you do it. Okay.